Hello everyone. I return again with another YouTube video on chemistry, and my camera sucks all of a sudden. Sorry about that. I should probably have fixed that beforehand. There, now I'm centered. Okay, so today's video is going to be on, well, not today's video, it's today's second video. Whatever. Okay, so ignore everything that just happened. Sorry about that. Okay, we're gonna have multiple videos today because my class needs them, and yeah, not like I know how to teach people is the point. Okay, so we're gonna do quantum numbers. After the last video, this is gonna be super more complicated. I need water. Quantum numbers is basically, what did I write it down? Okay. Quantum numbers tell us the position and energy of each electron. Okay, that's like, don't they have the same energy? Yes and no, because electrons are really goofy. We're gonna start off with a quick little thing about electrons and the atom to explain everything else all together. Okay, so the atom consists of protons, neutrons, electrons. Protons being positively charged, neutrons being neutral charge, and electrons having negative charge. Simple kindergarten stuff, okay? So, protons and neutrons are being held together in the nucleus because of strong force. It is the strongest, I think, of the four main forces: gravity, weak, strong, and electromagnetic. Believe it or not, gravity is the weakest of them. Total other concept of things. I don't feel like explaining it right now. Plus, we're already 3 minutes in. Neutrons. Goofy thing that happens when an electron and a proton fuse together, and it creates a neutron. Neutral charge, because negative plus positive equals. And the reason it's neutral is because the electrons are super powerful for how small they are. They are insignificant. You think the atom's small? You think protons are small? Nothing compared to electrons. Electrons are tiny. Electron, pretty much the main thing in chemistry. Like, if you think about action movies, electrons are the Brad Pitt. No. Okay. That was a really bad analogy. Basically, electrons run the show. They are on the red carpet all the time. Okay. They have a negative charge, as I told you before, and you already know because you went to kindergarten. Probably. Hopefully. They have 1/2000th AMU. That's how much they weigh. They weigh 1/2000th of an AMU. That's about, I don't even know how to describe it. It's like you're scaling a bag of cheese to the weight of a Prius. Or like this notebook to the weight of, like any random notebook. That's one subject notebook, not 5 subject notebook. Any random 1 subject notebook to the weight of a Prius, okay? That's how small an electron's mass is. But yeah, so much energy. It's crazy. They orbit the nucleus in different energy levels. We talked about this last time. These energy levels are S, P, D, F. Okay? I might be wrong on that, but I'm gonna say that's correct. For most chemistry tests, that won't matter too much. Okay? Ignore what I just said. Just that last itty bitty part that I just said is the only thing that matters. And electrons exist in orbitals, which is multiple different places where they can be. It is a super goofy thing, but the only way to measure electrons is by sending an electron to hit it. And when that electron that hits it returns, that's where it tells us where the electron is. But electrons can be in multiple places at the same time, due to them being, well, okay, not technically. Not exactly. They can be in multiple places because the time it takes for them to be in that place. Like they're here, 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 and here. And because of how their orbit works, I guess to say, it just changes everything up. They can be in multiple places at the same time for practical purposes. If we're being realistic or not. But for practical purposes and for timing and everything else, they're in multiple places at the same time. And those places are called orbitals. And each orbital can hold up to, but no more than, 2 electrons. Okay? That's electrons. Now, how does this get into quantum numbers? Each electron has its own quantum number. Okay? Those numbers are just like coordinates, technically. It's not like 1, 5, 7, 8. It's not a code. It's a coordinate, per se, more accurately. A quantum number tells you where that electron is on the periodic table. But like, it's got to be the highest energy electron of the atom in the periodic table. So for example, the highest energy electron, of helium would have the quantum numbers of 1, 0, 0, -1/2. That's the quantum number that relates to the highest energy electron in the atom, in an average atom, okay? An atom with the right amount of electrons. The highest energy electron in an atom of helium. The coordinate for that electron is 1, 0, 0, -1/2. 1, 0, 0, -1/2. Okay? So, basically, the first number is kind of what we did last video, okay? The first number is the row it's in, okay? So, helium is in the first row. That's where the 1 comes from, okay? Now, this next part gets a little goofy. Not as bad as the part after that, or the part after that, okay? The next part is the first 0 comes from the group it's in, okay? So S, it's a code, okay? So S, the code for S is 0. So it'd be 1S, right? 1S is 1, 0. 2S, 2, 0. 2P, P is 1, okay? P is 1, so 2P would be 2, 1. And 3P, 3, 1, and so on. For the P's and S's. Okay, so for the D's and F's, it works the same way as it does with the other ones and how it works with electron configuration, okay? It'd be The electron configuration, it'd be, you know how I said last video, it's if it's 4p in the row, the d would be 3, right? 3d. Well, it works the same here. Okay, it's the same thing. It's just then there's codes for the D and the F and the P and the S and everything. Okay, easy. The code for P or D, my bad. D, the code for D is 2. Yeah, the code for D is 2. Can you please stop doing that? The code for D is 2. Okay, so titanium is the code, yeah. The code for titanium, this is memory skill, by the way, so impressive. Eventually you'll be able to do this. It's the code for titanium is 3 to -1 1/2, right? So it's 3D, so 3 2, and that's the rest. I'm gonna explain it a little bit. But that's titanium's quantum number of the highest energy electron in titanium. Yeah, that's the quantum number for it. So I actually have a second periodic table, where I have 2. On this one, I wrote down all the quantum numbers for everything. Please focus, camera. Okay, that's the best it's going to focus. I don't care. But yeah, I wrote down all the quantum numbers. It's 3 2 -1 1/2. Okay, that's the code for D's. Easy. No, I'm not gonna make that joke. That code for F, as you would follow the pattern, 0 1 2 3. Easy, right? So like for any F element electron, it would either be 4 3 or 5 3. That's the easiest one there's gonna be, I think, for the first 2 digits, right? For the first 2 coordinates. The other 2 are gonna be a little goofy. And for the other 2, I have to explain orbital notation. Fun. And Hund's rule and Aufbau principle. Fun. Okay. So, let's pause here for a minute. We're gonna explain orbital notation. I don't like it a whole lot, but you gotta learn it in order to do quantum numbers, in order to do who knows what, right? Give me a sec. Okie dokie. Okay, so pencil, paper, orbital notation. You do the same thing. It's mapped out the same way as, okay, not technically. It's almost mapped out the same way. It's based on electron configuration. It's a form of electron configuration. I personally don't like it a whole lot, but you gotta learn it. It is what it is. So let's do something simple. For this, there is the Aufbau principle, right? Hund's rule and Aufbau principle. I was right. Okay, so Aufbau principle should be pretty simple to explain. Should be pretty simple to understand. The Aufbau principle means that an electron cannot be up here in this energy level if this energy level is not filled in, okay? This energy level has to be filled in before this one can be, okay? So what that means is the principal energy level, the first one that can contain up to 2 electrons, right? The S block. The first, well, 1s technically. That has to be filled in before the next group is filled in. So it's like you have to have all of these before you can start filling in these. If you only have this electron right here, the hydrogen electron, you cannot have it in the orbital or in the energy level that the lithium electron would be in, or the francium electron, or the mercury electron, okay? You can't have it there. You have to have the hydrogen electron there. Otherwise, you can't have all the other ones down there. You have to have the helium electron there in order to have anything bigger than 2 electrons. If the helium electron is not there, if that second electron's not in that second energy level where it belongs, in the first energy level, then you can't have electrons in energy levels higher than that, okay? Simple stuff. You gotta have a base before you have stuff on top of it. Simple stuff. It's like construction, basically. You gotta have the bottom before you have the top. Okay, that's Aufbau principle. Now, Hund's rule. I think I might have explained it. Okay, so Hund's rule, I'm pretty sure, is that you have to, this is from memory, by the way, I don't have it written down. 20 is Hund's rule, 21 is Aufbau principle, Hund's rule. Don't have it written down. So, Hund's rule is, it relates to orbital notation. In orbital notation, you have it mapped out the same way. We're going to go with 3s. Okay, so I drew this up real quick. I don't know which element this is. I'm going to guess it's 3s. 3p. Okay, it's the sulfur. So, see, it's 3s, and you have the 2 electrons for that orbital. That's be the 2, right? And you have the 3p, 1, 2, 3, 4. Okay, 4, that'd be sulfur. Doesn't matter what atom it is. It's Hund's rule means that you have to have an up arrow before you have a down arrow. So you cannot have a down arrow without having all the up arrows first. It cannot be like this. Okay, see how that is. See that? I erased it. Okay, mostly, but pretend it's fully erased, okay? For this, pretend it's fully erased. You're supposed to have an up arrow right there. You can't have that down arrow right there. You can't have it at all. You can't have it there unless that third up arrow is there, okay? You can't. That's Hund's rule, okay? You gotta have all up arrows before you can have a single down arrow. And that down arrow and up arrow is just referring to the spin of the electron to have it have an will you stop, please? To have it have a quantum number. The last number, the 1/2, -1/2, that's the spin of the arrow. That's the spin of the electron, okay? So, there's that. That's Aufbau principle and Hund's rule. So, going back to it, I forgot where I was at. We're gonna guess and say we were explaining orbital notation. No, that was orbital notation. Okay. Basically, we're gonna go into the next step. The next number, the third coordinate, okay? Say you have, let's go back to titanium, that's the name, okay. You have the 3, 2, -1, 1/2. Okay, the -1 comes from, this is a little tricky, but it's to know the orbital that's in. I actually don't know the explanation for it. But basically, 1, 2, so what you do is you divide the number by 2, you divide the column by 2, right? So you divide the group by 2. The S's you divide by 2, you divide into 2, I guess. Okay, and basically what the reason for that, I don't exactly know why. I can't explain it to you. But yeah, you just do that. And so basically you got to do it so you're counting, okay? Basically you're counting. That's the best way I can explain it. You're counting. So each group has to have 2 zeros in it. And those 2 zeros matter where they are. I don't know how to explain it very well. I know why. No, I don't know why. I know how to explain it, but I don't know why. So take, we're gonna go to P block, to the P block, 3P block. Okay, so aluminum. See, there's gotta be 2 zeros in the P block. So where'd be the perfect place to put them? Wrong. You're all wrong. Unless you said silicon and chlorine, you're wrong. You're wrong. Because of this. You go 0, and 1 in front of 0 is 1. 1 behind 0 is -1. That's really bad, but -1, okay? So aluminum is behind 0. So you put, this is -1, this is 0, this is 1. And since chlorine, you gotta have 2 zeros. 2 zeros. Okay, you split it in half. Okay? There's this half, and there's that half. Okay? You split in half. Okay? And one half has to have a 0, the other half has to be a 0, and the 0 has to be in the middle of each half. Yeah, we're going great. The 0 has to be in the middle of the half. It's whatever. I don't know. Okay, so 0 has to be in the middle of the half, and so that's, each of these is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, and the same thing applies to the -1 and the +1 and -1 and +1. But you can see there's 2 zeros, 2 -1s, 2 +1s for the P block. What? That's where the 1/2 and the -1/2 come in. I'll explain that in a little bit. I'll get to it. Okay? Because the S block has only 2 elements in it, it's got 2 zeros. So for the S block, it's always going to be the row number, 0 because it's S, and 0 because it has to have 2 zeros. Okay? So it's always going to be 1 0 0 or 2 0 0 3 0 0 4 0 0 5 0 0. You get the point. Okay, the S blocks are always gonna be super simple. Yeah, it's always gonna be simple. Don't worry about it. The D block. There's 10 elements in each row for the D block. Okay. I did that super wrong. Okay. Yeah, I did write that down. Okay, for the sake of this periodic table, there's only 4.5 lines, or 3.5 lines. But you only have 2 zeros split in half. It starts off at -2, -1, 0, 1, 2. Why? Because you split in half, and the 0 has to be in the middle of each half. So when you take 5 Or when you take 10, divide it into halves, you got 5 and 5. Well, 5, you got the center 1 and 2 on each side. The center 1 is 0. And -2, -1, 0, 1, 2. Easy. Easy. Now, the F block, same way. It's 14 elements across. It's 14 elements across in the 5F too. So, what you do is divide it into 7. Same thing as before. Now, the 0 has to be in the middle. 7 doesn't divide evenly. Notice that. The only one that divides evenly is none of them. I mean, they all divide evenly. Think about it. But what you do is you take 7 and see where the center of 7 is. It'd be 1, 2, 3, 4, 5, 6, 7. The 4 is the center. So it'd be -3, -2, -1, 0. Because the 4th one is the center. Over here, it'd be the 11th one. Or the 12th one. The 11th one. It'd be the 11th one over here on this half. And the 4th one over here. Okay? So, don't memorize where it is. Just look at the periodic table. Split in half. Split in half. Well, not split in half, and you have 2 halves now. And in the middle of that half is where the 0 is. And now just count down or up to get to the end of each half. But it's always going to be 1. Can you stop doing that, please? Thank you. The thing, there's nobody there. Okay, there's nobody there. It's just like physics. I don't know how to explain, but yeah. When you move forward, the thing moves forward. When you move back, it moves back. Airflow, and it's a thing. That's whatever. Okay. So the S block has 2 elements. It's got to have 2 zeros. Can you stop doing that, please? I think I'm stepping back too far. The S block has 2 zeros, and it's only got 2 elements, so both of them are going to be 0. The P block has 6. You divide 6 into 2, you got 3. So you got 0, 1, 2. Or 0, 1, -1. 0, 1, or -1, 1. So the 1 should be next to the -1. If it's not, you're doing it wrong. Okay? Yeah. And depending on which half it is how you determine the 4th variable, the 4th one. The 1/2 or -1/2. If it's negative, it's going to have a down arrow. If it's a positive, it's going to have an up arrow. And how do you determine that? Well, everything has to have an up arrow before it has a down arrow. Conveniently enough, you split in half, you see where the up arrow is and where the down arrow is. Or where the down arrow starts and where the up arrow stops, right? Casper messing around, I don't know. But yeah. And so with the P block, when you go 3 over, because it's -1, 0, 1. And so that's the first 3. And the P block, as I said before, split in half. I don't know where I said what I'm talking about anymore. I'm saying the correct stuff though. Okay, you split in half, and depending on which half it's on, that's how you determine if it's going to get an up arrow or a down arrow. And it's always going to get an up arrow if it's in the first half. Okay, in the first 3, it's always going to get an up arrow. It's the first 5 and the first 7. The first 1, it's always going to get it's always going to get an up arrow. Okay. The second half is always going to get a down arrow because you need an up arrow in order to get a down arrow. You need all up arrows before you can get all down. The rest of them to have down arrows. Okay. So that's why because the down arrow is down spin. It's spinning downward. The electron. They made it up. Maybe I don't know why, but it's negative because that's the spin, or the supposed spin, of the electron. And the 1/2 is, they picked a random number. They didn't want to have it like a second 1 or a second 2 or like a -10. Okay, I don't know why they picked 1/2, but that's quantum numbers. Quantum numbers. If I did a good job, you should be doing well. I guess, I don't know. If I didn't, just comment down below. I'll help you out, or I'll try to. Yeah, and do your best as always. Yeah, if you need help, I'll be here always for you and for your needs. So if you need any other subjects, help with any other subjects, biology, physical science, physics, I took them all. I'm taking chemistry right now, so that's why I created these videos. Yeah, unless it's environmental science. And as the channel says, I do more than just science. So if you need help with like anything except for economics, I cannot do economics. Yeah, econ is not my strength. Yeah. Thank you all for watching the video. I'll see you next time.